into the initial components and more importantly, the horizontal and vertical components of velocities when we're talking about projectile motion. So one of the biggest differences that you're going to see between what would have been covered in stage one physics is in stage one physics, we were dealing with one-dimensional motion, so motion that was going straight up and straight down or to the left or to the right. Where in stage two, we have velocities that are going on different angles. And because of that, what we want to ask ourselves is what are they doing in the two components, both vertical and horizontal? So if you look at the example that I've drawn up, this one is pretty basic. It's going up and to the right. So our components would illustrate that by having those two things that we've just mentioned, that being going up and to the right. So you can see I've got an arrow going to the right and an arrow going up, and I'm going to put a little angle in there. And what that's saying is that this here would be our horizontal component of velocity, and the one over here would be our vertical component of velocity. So they are the two components which are making up our overall velocity. So the red arrow or the red vector is the actual velocity. That's what's actually happening at this point in time. The two black arrows and vectors are representing the components of that red vector. Now, what I'd be saying is if I look at this, I can see pretty clearly this is a right angle triangle. And if I focus firstly on VH, I can see that this is adjacent to the angle theta here, and that V is the hypotenuse. So if I were to use cosine, I'd have cos theta equals the adjacent side, which is VH, over the hypotenuse, which is V. And if I rearrange that, I'm going to get VH equals V cos theta. And likewise, if I did it with this one, I'd say that vertical is the opposite. So therefore, sine theta is equal to V vertical divided by the overall velocity. And therefore, V is equal to, let me do that again. The vertical velocity is equal to V times sine theta. So we get two really important statements, and that's that the horizontal component of velocity is V cos theta, and the vertical component of velocity is V sine theta. So what that means is that if you're given a question and we're dealing with a pretty basic sort of scenario to start us off, let's say I've got this velocity which is going up at an angle of 31 degrees, and the velocity itself is 11 meters per second, and I was asked to find the two components of this particular velocity. If I was finding VH, I'd be using V cos theta. So the V is 11 times cos 31, and I would get an answer. And same with the vertical component of velocity, I'd just be replicating what we've got there, which is 11 times sine 31. And if I put those two answers, put two calculations into my calculator, I'll get 9.43 meters per second and 5.67 meters per second. So that's my horizontal component, that's my vertical component. Given that the angle is less than 45 degrees, it would make sense that the horizontal component should be bigger, given that it's going across more than it's going up. And if it was the other way around, if it was more than 45 degrees, then we would see the vertical be more than the horizontal. So hopefully that will help you get a good understanding of the basics of the components of velocity.